So hello guys, this is going to be the simplified version of the common nodes explained video. I just finished recording a 1.5 hour video where I explained all of this in detail, but this video is going to be the simpler version where I try to go over it faster, not going into much more detail. But if you want to learn it in much more detail and understand it in much more detail, please watch the big video. But this is going to be a faster, simplified version where you just want to quickly get over it and understand some basic of it. So first thing first, we have floats. So float 1, float 2, float 3, float 4. These are also called vector 2, vector 3, vector 4. These are nothing but values like 0, 0, 0, 0, 0, 0, and this one is also 0, 0, 0, 0. So these are nothing but floats, and all of the stuff is made with floats. So for example, if we check in this common nodes, if I turn this into default node, this is float 1 because only one value, specular is 1, metallic is 1, base color is RGB because 3 values, opacity is going to be float 1 because it's also 0 to 1, normal is float 3 or vector 3, and this tangent is also vector 3. So again, if 3 floats are used, it's called float 3 or vector 3. Then we have addition, subtraction, multiply, divide and power, which I'm going to just add here. And again, these are like very basic mathematics, so I'm not going to tell you based on the numbers, right? So I'm not going to show that 0 plus 1 is 1, 1 minus 1 is 0 and all that stuff. We are just going to use it based on the texture. So if I take a texture by pressing T and doing left click, I can take my noise texture, which is noise 1, like this. I can take a radial gradient exponential, which again, I'll turn this into an unlit material, okay, which is nothing but a radial exponential like this, or radial gradient. One important thing is, in a texture, whatever is black is 0 and whatever is white is 1. So if I take this color ramp and basically move it opposite this way, wherever in this pixel is 0 is black, okay, and wherever in this pixels, wherever there is 1 is white, and wherever there is 0.5, it would be the center color, 0.1, 0.3 and all that stuff. So a texture like this texture is nothing but float values at different pixel values, pixel locations. So for example, this, let's say this is like fully white, then it would be 1 at this location. This one would be 0.2 or 0.3 because it's grayish color, and like each pixel would have its own float values. So whenever we do this arithmetic maths, right, add, subtract, multiply, divide, what we are basically doing is we are checking this pixel point. We are checking, let's say, this pixel point, and then checking this pixel point from the second texture and adding that pixel point. Just like if I take this 0 plus 1, we are going to get 1. If I do 0.5, we get 0 plus 0.5 is 0.5. 0.5 plus 0.5 is 1. So we get white. 0 plus 0.0 is going to give us 0 is going to give us black. 0.1 is going to give us 0.1. So each pixel from this texture is going to get added with that point in the second texture node or whatever you use around there. So you could see that the middle area just turned to this white color stuff. If you take this into subtract, it is just going to do the same things, and we get this one. So we subtracted this gradient in the center, and when we do subtract, it is obviously going to be different based on where you put the A input and B input, because 2 minus 1 is not equal to 1 minus 2, but 2 plus 1 is equal to 1 plus 2, like that. So just keep that in mind. Knowing where you're subtracting would actually help you understand. Next is multiply. Multiply again would be easy to understand. Wherever there is 0, we will multiply it by 0. Anything multiplied by 0 gives us 0. Anything multiplied by 1 gives us the same value. So like 2 multiplied by 1 is 2. 21 multiplied by 1 is 21. And then 0.5. So 20 multiplied by 0.5 would give us, 10. So there are like different values in here, 0.1, 0.2 and all that stuff. So when you add it into multiply, it basically acts as a mask. So it acts as a mask. Then we have a divide. Divide also does the same stuff, but I don't really understand it much in detail, like where we use it. I've not used it much often, so I'm just going to show this much. I'm not going to go in much detail. Just one thing I can tell you is that 1 divided by 0 is going to give us black. Okay, So we are not going to get any infinity and all, obviously, but anything divided by 0 is going to give us something like this. Now, before we going to power node, I'll give you one more stuff, which is called saturate node. This saturate node is nothing but a clamp node. Only difference is that with clamp, you can actually choose the higher and lower value, but with saturate, it's going to be 0 to 1. So when we add, this texture and this texture, like this, so this texture, let's assume this is 1, and let's assume around in this one too there is 1, because it's a, you can see it's 1 around here. So 1 plus 1, it's going to go above 1. So 1 plus 1 is 2, so we will get 2 here. But if you do saturate, what this does is that it clamps it. So any value which is above 1 would turn to 1, any value which is below 0 would turn to 0. And this is important because lots of the time you need to have values between 0 to 1, like using in Lerps or any other mathematical calculation, because -1 is also going to look black and 0 is also going to look black. So you cannot just go by your eyes. You need to know which value is which. Like doing subtract by this would obviously lead to, this could be -1 or -0.5, whatever, based on the pixels, right? So when you do saturate, any negative value would turn to 0. Clamp is different. It just allows you to choose the values. Any value above 0.5 turn to 0.5. Any value above 0.1 turn to 0.1, like that. And same with minimum. Any value below 0.1 turn to 0.1, like this. So let's explain power node. So right now this is how it looks. If I connect it to the power, we can control contrast with it. Okay. And the thing you need to know is that when you use power, it is same as multiplying. So exponential 2 is same as multiplying this texture twice. You could see if I connect it like this, it is going to look the same. If I turn this to 3, then it is same as doing multiply 3 times. So it is multiplying with itself 3 times. So it multiplies base with itself this many times. And one feature you need to know about, or one thing that you need to know about power, is that whenever you give 0 to 1 value, the lower values get decreased drastically, but the higher values don't decrease that much. Like 0.2, so in a texture, wherever there is 0.2, if you do exponential 3, it turns to 0.008, because 0.2 multiplied by 0.2 multiplied by 0.2 turns to 0.008. 0.9 multiplied by 0.9 multiplied by 0.9 would just turn to 0.729. So what this leads to is black areas getting much more darker, but the higher values, like white values, don't get that much decrease. So it creates a nice contrast, and you could increase like the black values like this, you could see, with power node. If you check the detailed video, which is like the bigger video, I explain the graph of it. So please check it if you want to learn in much more details. Next thing is the texture coordinate. It is used for UVs. So this is UV. So this is float 2, U and V, X, Y, RGB. All of them are like floats. These are nothing but 2 numbers. That's all that is. Okay. So this is used for tiling. So if you take a texture, something like this, add it RGB, add it to UV, we are going to get the same. But if you multiply this twice, sorry, 2 times, we get multiplying it with 2 times like this. I would highly suggest watching this video called Shader VFX Fundamentals, in which I go in much more detail explaining the UVs and stuff, like how these are calculated and like basics of stuff like this. I go into much more details for it. So just keep that in mind, that we can actually multiply and do tiling, but you don't always want to tile in both U and V's, which is X and Y. Okay. So what you could do is you could take 2 vector and add it in here. If you multiply by 1, we get the same. Now if I do 2, which is we are multiplying the V with Y. Now X, Y, RGB, UV doesn't really matter. Okay, whatever they use. The thing that matters is the float values. So UV, you can multiply UV, X, Y, RGB, nothing matters, just the float values. So right now we are multiplying the U's with 1 and Y with 4, like this. You can do 5, and basically you could see only does it in that direction. One important thing you need to understand, whenever you're doing arithmetics like this, you can only multiply and add like all this subtract stuff only arithmetic with float 2 and float 2. So you cannot do float 2 and float 3. You cannot do mathematics like this. You cannot do all of this. You cannot multiply float 2 with float 4. But what you can do is you could multiply float 1 with any of this. Okay. And what this basically does is that if you multiply this 2, and let's say if I turn this to 1, 1, if I do 2 in here, it will turn to 2, 2. So it will multiply 2, 2. But if I do something like this, which is 3 and connect it, and if I connect it in here, I'll get an error. Like float 2 and float 3 are undefined. So that's why when we did, one single float in here, it is multiplying with both u's and v. But when we do this one, it is multiplying the u with the this value x and v with this value y. Now one important thing is you cannot turn this into a parameter, right? So convert to parameter, and when you use for material instance, it's not going to work. It basically, when you do convert to parameter, it turned it into, this 4 parameters one, like 4 float 4 or vector 4. We don't want that. We want to do is we can take 2 parameters, single floats, and we can say append many. Not this one, sorry, append vector. And what this will turn is, it will take these values, which is 1, 2, and it will turn to 1, 2, and then we can add this. And this way we can convert this to parameter and use it in our material instances. That way we can have control for x and y separately. There is another node called append many. This is nothing but a material function. So if I double click on it, you could see it is just using append nodes. Okay, it's doing just appending a like r and g, then it is appending b, and then it's appending a. So this one would give us r comma g. Then if I append it again, it's going to give us r comma g comma b. And if I append this, it's going to give us r comma g comma a, rgpa. So if you want to append multiple of them, then only use this. Else there's like unnecessarily extra nodes used. If you're just going to do for 2 of them, just use append vector. If you're going to do 3 or 4, then use this node. Next thing is, when you add something to the u's and v, you can actually move it. You could see 1, 2. Basically we are moving the coordinate systems that I've explained in this video. So again, this is how the coordinate is. Okay, and because a texture is repeating texture, it is repeating. Okay, so when we do multiply something like this, you could see the texture is actually repeating. We are just saying that, hey, scale it this much only, like this. When we use like u is like this. Okay, so that this is only how much it should show around here. But when we do add, when we do 1, 2, you could see no difference is happening, but actually there is difference. It is just we are moving it like in equal distance in a grid. But if I do 0.5, you would see that it actually moved only half of this distance. So what this means is that if you take a node called time, you could use something called debug scalar value. This is just for checking the values. You could see it is nothing but a float value which is just increasing, like float 1 which is constantly increasing. If I add it in here, we are moving in one direction. And obviously if you do append vector, do this, connect it like this, 1, it is now going to move in one direction only. So time node is basically used lots of the time for animation because it's a constant float value which is constantly increasing. Now instead of doing all that, we have a node called panner, which you could just do p and then do left click and it will just show it. And you could just do 0.5 and 1 like this. You could just play around with it. Okay, and again this is a float value, like 2 floats. So if you do promote to parameter, you would see it's only giving us. But that's why I explained to you about append vector, because it's 2, right? So you would create 2 of them and append it. Okay, if you want to create parameter. So again, play around with it, just speed and all that stuff. You could even go in here and add like a time, multiply this to kind of like increase it. So whatever you add in here, it will just do double, triple like this. Or you could just turn this into 5 and that's going to be the same. And again, this is the coordinate. So if you add in here, multiply and all that stuff to do tiling and stuff. Then we have rotator. Again, I'm not going to go in much detail, but it basically rotates. And in here, we do not have a point to control. So what you would do, you take a time node and multiply it by something. So I like to do speed as 1. That's basically like the basic speed, and then you take time, multiply. So you can do 0.5, 0.1 and all that stuff around here. And this is like center and all that stuff where you want to rotate it from. Now let's take Lerp, like this Lerp, okay, which is linear interpolate. So if you search for Lerp, it will say linear interpolate, or you could do L plus left click because it's very commonly used. This is very commonly used node. So if I take it to this one, you could even tell from here it is saying A0, B1. So I'll explain what that means. So if I do blue, green, this is how it looks. If I do 0, it is going to show A. If I do 1, it is going to show green. So based on the alpha value, it shows these colors, which means that if you use a texture in here, and add it in here, you would see that based on the pixel value in here, we get different ones. So wherever there is 1, we get this one, like this B channel, because you could say it's by default saying 1, which means it's going to be showing this one. You could make it darker. Sometimes it might not be visible if you use both as a bright color. And this is how you could actually color based on a texture or any mask, okay, black and white mask. And you can actually keep lerping on it. So you could add another one in here, another texture, add like something else color in here, like pink color, but this texture should be different. And you could keep like stacking it on top of each other, okay? So I'll explain Fresnel first. So Fresnel node is quite commonly used for something which requires like a rim light. You could see all of these orbs which I have video on my channel. They have a rim light, and that is made with Fresnel. Fresnel, if I show you, you could see that, let me turn this into this way. You could see that wherever there is at edge, it is 1. And as we go into center, it starts going to lower values, maybe like 0, 0.1 or something. And there is like fading out, like it's not white. It is going from 1 to like lower values. So 0.9, 0.8 or something like that. And this one, if I show you in a mesh, if I go to my normals, it is done by this, okay? So any normal based on the vertices, right? So any normal which is facing perpendicular to me is white, because that means that there is a rim light there. And any normal which is facing me directly is going to be 0. And based on the direction, it is going to look different. So how much it is facing perpendicular. So if this is facing, it is not completely perpendicular to me, which is like 90 degree to me, then it would not look that much white, like fully white, and we get this gradient. And obviously you could use a power node in here to intensify the effect, like this. Then I'm going to take my texture coordinate again, and I'm going to show you another node called mask. Now just like how our texture coordinate is like 2 floats, like U and V, this is like 3 floats, this is 4 floats, this is 2 floats, and all that stuff. A mask allows you to just take like extract one value. So if I take R value, I'm just going to get the U channel from here. If I add it in here in a plane, let me add my background, we get 0 to 1. You could see this is how the UVs are. Now what we are basically taking is, we are just taking the first value. So 0, 1, 0, 1. So it goes from 0 to 1 like this, and we get a black and white texture. Just like I said, 0 is black, white is 1. If we do G channel, it goes up to down. You would see 0, 0, 1, 1, the right value, because we are just extracting the right value. This is only going to give us float 1 because we are only choosing float 1. If I do R, you could see there isn't any value in there. If you do R and G, no changes because it is taking both of this, okay? So if you take a 3 texture like this and then add here, it is only going to give you R and G. But there are also another nodes, and it is called break float 2, like this. Now in the past, I used to be able to just do like this by dragging it, but it does not. You have to click on empty area, and there is like break float 3 and break float 4. And what this basically means is that instead of creating 2 mask channel like this, you could actually just use one break float like this, and it will give you the first float and second float. If you use a 3 RGB, then you get this one, R, G, and B. And just like we have float 2, we also have make vector 2. I don't know why they have named one float and one vector, but make vector would basically just, it will take two values and then turn it back into this one. You could even do two values like this and connect it into a vector 2. So let's take our mask again and let's do our channel. And now this is 0 to 1. So there is a node called 1 minus x. So it is called 1 minus, but it is 1 minus x. And you would say it actually reversed it. But there's one important thing you need to know. It is not reversing it, it is doing 1 minus whatever values are in here. So 1 minus 1 is going to give us 0. 1 minus 0.5 is going to give us 0.5. 1 minus 0 is going to give us 1, which basically turns it into opposite. Which means that if the values in here were above 1 or negative 1 or anything different, then it would not look same. So if I do add of something like, let's say 0.1, it would look a bit different. Okay, so even though this is how it looks to my eyes, so I cannot tell from my eyes, right, what values are there, but in here it changes like this because we are doing 1 minus whatever values are in here, which is basically going to be like 1 plus 1 plus 0.2, so it is 1.2. 1 minus 1.2 is minus 0.2, and this is how it looks. Then we have absolute. Absolute basically does is that it takes the negative values and turns into positive. So negative 5 would turn to 5, negative 2 would turn to positive 2, sorry. So negative 2, 2, negative 3 turns to positive 3 and all that stuff. So if I take this into emissive, nothing's going to happen because there is no negative values. But what if I take this one and do 1 minus x, 1 minus, then this is still going to be, 0 to 1 value. So this is 0, this is 1. But then what I'm going to do is I'm going to just do a subtract both of this. So I'm going to take 0 to 1 value and then subtract this. So what's going to do? 0 minus 1, negative 1, which gives us something like this, which looks like it is, if you look from your just eyes, you would think that, hey, this is 0, this is 1 and this is 0, right? But no, this is actually negative 1 in here. So if you check in here, 0, minus 1, negative 1. So if you give it to absolute, we get a beam light effect. Because it was negative 1, it turned to 1. For these three nodes, I'm just going to go quicker because in the bigger video, I went into much more detail for it. But a Frac node is nothing but it takes if you take a debug value, if I use a debug scalar value like this, add to result, you would see we are getting only the right value. So what this basically means is that if I take 5.3, it is 5.36, it's only going to give me right value. It removes anything that is at the left of this stuff. So it is good for creating a loop which is like 0 to 1, 0 to 1. A ceiling node is nothing but it is just going to take any decimal like this. If I do 0.5, it will turn to 1. If I do 1.5, it will turn to 2. 1.2, it will take to 2. So higher decimal, higher number basically. If the floor is completely opposite of it, so if it do 1.2, it will do 1. If we do 1.9, it will do still 1. If I do 2, it is going to be 2. There is also round. Round is again basic stuff. 1.5 is going to be 2. 1.4 is going to be 1. So 1.5 and above, like 1.6, are just going to be 2. Anything below 0.5 turns to the lower number. Anything above 0.5 turns to the above number or higher number. I'll explain bump offset pretty quickly. So bump offset is used for parallax effect. So if I take my texture like this, add it into my UVs, go into this, we need to add a height. By 0, no effect. 10 means it's closer to us, and you could see the weird effect because it's closer to us, and negative 10 means it's further from us. And take the texture sample, say that it is clamped, so it's not repeating, and we get this. We get this stretching effect because this texture, you could see, is actually touching this edge. So when you want to do clamp, it should not be touching the edges, okay, else it stretches. This allows you to create, like the bubbles that are stuck into the eyes, the tiny bubbles, or create like different pattern. You could even add a texture in here like an RGB texture, oh sorry, not RGB, a grayscale texture, and add here, and nothing's going to happen because it's 0 to 1. The height is like not that much. If I do multiply, negative 10, so we are just putting it below and we get this effect. You could see, based on the texture we are multiplying, right, each pixels. So wherever there is 0, 0 multiplied by -10 is 0, so no effect. But wherever there is 1, -10. So I'm going to explain this nodes pretty quickly. It's very basic ones. So again, I'm going to do my mask, or actually, you know what, there is a node called linear gradient, and that does the same thing. So if you double click on it, it takes a UV coordinate and then it masks the R channel, it masks the G channel. So you could just use this node too. But again, it's better to use, if you know that you're not going to use the G channel, it's better to do it yourself, so that you are not using, you know, extra information from these nodes. So if I just use the U channel, we get the U channel like this. So the step node is very basic. If I do 0.5, anything below 0.5 in here turn to white, anything above 0.5 turn to, wait, actually let me check. So anything below 0.5 turn to white, anything above 0.5 turn to black. But if I use it in the X and turn this into 0.5, it will be opposite. So anything below 0.5 turn to black, anything above 0.5 turn to white. It's good for creating something which doesn't require, you know, gradient, just like harsher contrast related stuff. Then SmoothStep is same, except we want a gradient. So just keep this in mind, that if you drag this and do SmoothStep, it actually doesn't connect it into the value pin. So you have to connect it into value pin. It used to create like bugs for me. So right now what we are basically saying that anything above 0.5 turn to white. So anything above here but still create the gradient. And if I do 0.5 in here, you could see till 0.5 it is turned to black, but we still have that gradient. Then we have a distance node, and for distance I will use the UV coordinates, add into A, and I will say 0.5. What it does is that it just compares the both values. So in here, this location is 0.5, 0.5. So if this is equal to 0.5, we get like black, like how much distance it is. So it is equal to 0.5, right? So it's black. And this point is 1, 0, right? Yeah, 1, 0. So how much further it is from it, that's how white it would look. So closer to it would look black, and further to it would look different. So if I do 0.8, it would be around here. 0.1, 1 is around there, 0.1 is there. If you do mask, we get a line in center. Okay, because we are just now comparing each of this point, how far it is from 0.5. And then you go to 0.8, we get a line around there. Then we have a sphere mask. This one requires a texture coordinate. B is 0.5, I think, and this one is 0.5. Yeah, I don't understand this, but this is what values we use, and the hardness allows you to control the hardness. And I think this one is responsible from where you want. Okay, yeah. So if you do 0, it will be around there. 1 would be around there. And it is basically comparing with UV coordinates. So if you use 2 nodes, like 2 of this, then it will be 1. So 0, 1, 1, 0, like this. So if you want to create a sphere mask, this is nothing but the radial gradient exponential. Again, not going to go in much depth. I've already explained that in other video. The last ones are sine, cosine, and dot. This I actually would tell you guys to just check the part of the detailed video, because that would help you a lot. But one thing I would explain to you about this one is a sine wave goes from, I think it's in here, a sine wave. So let me hide this. Goes from 0 to 1 to -1. Okay, a cosine wave starts from 1, goes to -1, goes to 1. And then each one of them have a period. So this period and period. So one period lasts for 2 pi, which is this much. So it's nothing complicated. It's just saying that this is one wave. Okay, so one period lasts for this much time. A period is nothing but how much one of this wave is. Okay, so when we use 1, this is how much it is, but when we do 0.5, it is going to go like 2 times, because 0.5, which is like 1 by 2, right? So 0.5 would do this wave 2 times. If we do 2, then it will basically just, if we do not 0.2 but we turn this into 2 like this, the wave would basically stretch and basically turn into a lot bigger. So this is how much it is like now. Okay, so this is 1 and this is 2, right? So what this would do is it would turn into just one wave like this in the period of 2. So again, the bigger video is like much more detailed for it. I'll draw and stuff in that, but I don't want this video to be bigger. And the only difference with sine and cosine is sine starts from 0, cosine starts from 1 like this, and then it goes like this to -1. And you could even tell by giving a value in here. So right now the sine is set to 1. Okay, so 1 period. At 0, it is going to give us black. It is going to give us black, which is 0. If I do 0.2, you could see it is going to be somewhere around here. If I do 0.4, it is still white. It is actually going down. And if I do 0.5, it is at the half of this period, which is around here. You could see. So 0.25 would be around here, which is fully white. And then 0.5 would be this. 1 is also going to be black. So from 0.5 to 1 like this, it went from 0 to -1 to 0 back. So one technique that we actually use is we take this sine node. Okay, and because we usually want values from 0 to 1, right? We don't want from -1 to 1. What we do is we add 1 and then we divide by 2, and this basically turns this sine node from, it starts from 0.5 but then it goes to 1 to 0, 1 to 0, and I've explained in the bigger video. Okay, so I don't want to go into much detail. You could even search for sine remapped like this one, and if I double click on it, it is doing the same stuff. It is taking the sine node and it is doing constant bias scale, which is nothing but it is adding 1 and then dividing by 2, which is 0.5. So if you don't want it to start from 0.5, you could use cosine, but cosine would start from 1. Just keep that in mind. So instead of this, you will just type cosine. You would use like cosine because cosine starts from 1, not 0.5. And usually you use with time node like this, and we get this blinking effect. So you could create like light related stuff like blinking cars, just like some stepped animation and all that crazy stuff. Okay, so I'm not going to go in much detail, just watch the big video. Then the last one is dot, and I've already explained it in here. I'll try to explain it back. So when dot product is nothing but comparison of two vectors. So when two vectors are at the same, like parallel, it gives us 1. If they are perpendicular to each other, it gives us 0, and if they are facing opposite, it gives us -1. So a dot product is nothing but a comparison stuff for two vectors. And so if I take my vertex normal, which I already shown you guys that this is my vertex normals, and each of them are facing different directions, you could see. So if I show you this one, this is actually facing up, so it's 0, 0, 1. A vector direction is actually normalized, so it's always going to be between 0 to 1. Something that is facing perfectly to me, it's in y, right? So it would be 0, 1, 0. This one, which is this one, would turn to 0, 0, -1, because it's looking opposite. And all of these values would be like different, like in decimal points, all three values. What we can do in here in our material is that we can compare all of these normals with 0, 0, 1. And if it looks weird in here, but if I use a sphere, you would see the difference. So we are comparing it with up vector, so up direction, each of these vertex points, and this would give you the up direction. It will give you like a mask where the top part is white, the bottom part is black. This is -1, so you could even do saturate. so that the bottom part turns to 0 instead of -1, and you get like this nice gradient where you could add snow on top, moss on top, and all that stuff with just this one where we just compare with dot. And if you do comparison with 0 1 0, we get this this wherever there is green, you could see green area, which is y, with 1, and this one to be 0. You could even check my slope video, like this one, auto slope material, in which I actually use this technique to create the this top part as grass and the side part as the ground area. So again, I've explained all of this. If you want to learn more in detail, I have a big video on it, just watch that. And this one is a quicker video, so didn't really go much in detail and explained it quicker. So yeah, thanks for watching. Goodbye. Subscribe.